Hello YouTube, this is our first video in our module on approaching adding and subtracting rational expressions. So essentially, adding and subtracting fractions, and as with numerical fractions, we see here the procedure used to add or subtract two rational expressions depends upon whether the expressions have like or unlike denominators. So I suppose the one thing we want to make sure we mention here is to add or subtract rational expressions with like denominators, we just add or subtract the numerators and place the result over the common denominator. So we must have a common denominator. So must have a common denominator to add or subtract. Denominator to add or to subtract. So that being said, we're just going to look here in this video at a set of rational expressions that already have what we call like denominators and the process that we use to kind of go ahead and add together and simplify those expressions. So if we look at this generalization here, we say letting a, b, and c be expressions, this could be any algebraic expression, as long as c doesn't equal 0, then we see that a over c plus b over c would just be a plus b over c. So we've added the numerators and put it over the common denominator, or we would subtract the numerators and put that over the common denominator. So looking at a couple of examples here, essentially, we're seeing in this first example 7 over 4x plus 3 over 4x. Now you'll notice that our denominators, a couple things about it. First of all, we already have a common denominator between these two rational expressions. And second of all, our denominators include an x or a variable expression. So if we were to add now 7 4x's plus 3 4x's, we would just go ahead and add the numerators, which gives us 10 over 4x. And you will see here that there are going to be times where, like 10 over 4x, we can simplify this down into what they give us as 5 over 2x. So with subtraction, same story. We can see here that both of these have a denominator of x plus 6. So if we have a common denominator, then again, we're still going to have this denominator here, and we're just going to go ahead and subtract the the numerators. And so we see we get 2x minus 5 on top all over an x plus 6. So that being said, this is pretty straightforward. You either add or subtract the numerators and put it over the common denominator and simplify if possible. So let's take a look at these examples we see over here where we've got a bunch of expressions, either sums or differences, where we already have like denominators. So with number 1 here, we see that we have this 8 12x's minus 5 12x's. This would be 8 minus 5 over 12x, or in other words, we would get 3 over 12x. Now, we would be responsible for putting this in simplest form, meaning that we would have to find any common factors other than 1 between the top and the bottom. So what we get here is this 1 over 4x would be our final expression here. And I suppose it'd be worth noting that x is not allowed to be 0 in that final expression. So looking at number 2 now, we see that we have 2 over 3x squared plus 1 over 3x squared. Adding those together, we'll just go ahead and say this is very straightforward here, is 3 over 3x squared. Whereas, we did in the last one a reduction by a factor of a common, factor of 3. Here we have a common factor of 3, except for they are both 3 themselves, so we get 1 over x squared here. And again, we should say that x is not allowed to be 0 in this expression right here. So looking at number 3 here, we notice that right off the bat, we could say looking at these, x should not be allowed to be 2. And also we have a common denominator here of x minus 2. So we'll put this over an x minus 2, and what we get is 4x minus x. So in other words, we get 3x over x minus 2. And one thing that I want to make sure we do here is quantify this, because 3 times x over x minus 2, the top and the bottom share no common factors here, even though some people would be inclined to think that those x's hit the road. Everybody would have to have an x, or the top and the bottom would both have to be listed in factored form. So no common factors between the top and the bottom. We would say that this is our rational difference here. And also we would say that x should not be equal to a positive 2, because we would get an undefined statement. So lastly here, we get 2x squared over x squared plus 1 plus 2 over x squared plus 1. We'll just go ahead and add the numerators, 2x squared plus 2 over x squared plus 1. And one thing that we want to make sure we do here is simplify if at all possible. I noticed that on the top they have a common factor of 2. So if we rip that out, we get 2 times x squared plus 1 all over x squared plus 1. And the neat thing about this is we have a common factor on the top and bottom. So we just get left with 2. And one thing we want to check here is this: are there ever going to be any x values that would cause x squared plus 1 to be 0? And so setting this equal to 0 and solving it, we see pretty easily here that we get the square root of negative 1, which comes out to be a non-real result. So we get plus or minus I, but this is non-real. So in other words, there are no real x values that will restrict this here, and what we end up with is just an expression that comes out to be 2. So in the next video, we'll take a look at what we do when we have no common denominators and what we do to remedy that situation. Cheers.